Okay, let's start example 7.2.1 of MMP. So this is example of parachutist. So we want to find the velocity of a falling parachutist as a function of time, particularly interested in constant velocity. So that comes by air drag. This velocity comes by air drag. So this is shows with the formula of this minus bv square, because it's moving opposite to the direction of motion. Okay, so negative sign shows that this is these air drag which opposes the force of gravitational force which act on the parachutist by earth. Okay, so we choose a coordinate system which is the positive direction, which is obvious in the downward direction, so that the gravitational force must be positive. So for this, for simplicity, we assume that parachutes open immediately at time t0, and we have to find the velocity, okay, which is 0. So first we have our initial condition is what? First we have to apply the Newton's law, which is to be applied of the on the falling parachutist. Okay, so you can see, and this is the formula for which is force which is equals to ma. So acceleration can be written as the rate of change in velocity, so mv, and this is the first order derivative, okay, of acceleration. So equals to this the gravitational force, which is weight, minus bv square, which is the air drag, okay, which is applying on the opposite direction. So this is the information that m is the mass. Okay, so the terminal velocity can be found from the equation of motion. So what you can see, the time is always on infinite, okay, where there is no acceleration. So it's mean that we have to assume that time is always infinite, so the velocity will be 0. This is the rate of change in velocity. Okay, so this equation, this element will be 0 by this dot product, or sorry, the first order derivative of this acceleration. Now further, you can say we are left with these terms. Now you have to arrange it. We'll get this bv square equals to mg. Okay, so further, let's see what happened. Okay, now you have to apply further, uh, take the value of this velocity, which is orbital terminal velocity, or we can say this is the velocity of a falling parachutist. Okay, so this is the square root in which the mass into gravity over b. So here what is b? If we talk about the b, which is actually the damping coefficient. Okay, so what is damping coefficient? Damping means when the system loses its energy, okay, with motion. So this damping shows. Okay, so further you can see, now take this equation again, okay, and arrange it. So now you have to using equation 1, okay, this equation bv square equals to mg. So you have to put the value of mg, okay, and in second equation, in this equation, sorry, using 1 you have to apply mg value. So now you have to take the common b and divide it with the left terms. Okay, so this is the value, and this is the degree notation of the first order derivative. So you have to put the derivative in the form of differential notation. So for that, you can see, now you have to separate the velocity values and obvious with respect to t constant values are different. Okay, so using partial fraction, now first we have to find this term value. So applying these partial fraction on these left equation, so this is the equation term. Okay, so this is a and b, and applying you know very well how to solve the partial fraction. So we will get these term actually. Okay, after getting these term, now further you can see what happened. Okay, so now we have to integrate on it. Okay, we have find already by partial fraction the value of this derivative of velocity, so you have to put it down there, and uh, these damping coefficient over mass is constant, so we have to apply derivative in time. Okay, so we'll get t, so there is some constant. Okay, now further you can see after arranging, okay, after applying these integration individually, this is the log term. Okay, these two are always the log terms after applying integration. Now by law of logarithm you have to uh, put it these minus in the form of this quotient. Okay, solving now for the velocity we have these terms. Now further you can see this term will go towards right and multiply with these both terms, so these velocity to v and velocity and c is always constant. V is 0 at time infinity, so we can say this is the constant term. You again you write it down as c dash instead of these terms, so the remaining terms are same, and now we have to let these term. Okay, t equals to this damping coefficient over b as sorry, mass over damping coefficient into velocity. Okay, so further you can see this is the previous equation. uh, okay, now you have to put these b over m, okay, and this velocity in the form of this formula. Okay, now you have to arrange the formula and you will get these capital T. Okay, this is the reciprocal, this is the reciprocal of this term, so you have to put this capital T, okay, in denominator, and plus c dash remains same. So at t0 and v0 now we have to find further. Okay, now you can see we will get these at t0 and velocity 0, and we will get only these term. Okay, and this is the constant term, c is 0. Now we are remaining with these 2t or capital T. Okay, and this is the time. Okay, and so after removing this log, we have to apply exponential logarithm. Okay, so this is the exponential logarithm, and we will get this term. I know you know very well that how to solve with this. Okay, so further, and this division term will go towards right and multiply with this exponential value. Okay, we have to separately multiply with the terms with this exponential term, and after arranging we will get these velocity. Actually we have to find these velocity of the falling parachute. Okay, so this is the velocity of the falling parachute at some constant terms, which is the vo and time. Okay, so now you can see this is the hyperbolic formula. Okay, hyperbolic notation of this exponential minus 1 and in plus form. So you can write down instead of these terms the sign hyperbolic and this term t over t. Okay, so and this sign over cos equals to this tan hyperbolic. So this is the solution required. So here is the example solved, so you must have to watch these. This is very important. Okay, so here you can see that some values are given, and g value which is 9.8 meter per square. Okay, which is the gravitational force, gravitational value. Okay, and this is the damping value which is 700 kg per mass, and mass which is 70 kg. So this is the formula. Okay, we have to find the velocity. Here we have to find the velocity. You can check it down in the notes. Okay, so after putting some values you will get these term here. The second condition is this: we have to find the value of 1 meter per 1 meter per second. Okay, so you can see that 1 hour, which is equals to this 3600 seconds. Okay, and in order to get the value, we multiply speed with 3600 and divide the result with this 1000, and so you will get this term 0.36 kilometer per hour. So 1 meter per second is exactly equals to this 0.36 kilometer per hour. Okay, this is the velocity which is equals to this term. Okay, this is all about from my side. Thank you. If you have any question, ask me in the comment section.